A very good morning to everyone who are joining us today. Welcome to all school students, teachers, parents from all around Malaysia. Not forgetting all UNS students and all UNS staff present in this session today. Thank you, and we meet again for today's sessions of STEM Speaker Series. First of all, I would like to introduce myself. My name is Ichimoy. I am a second-year student from Faculty of Psychology and Education, taking the course Education with Science. I am your moderator for today's sessions. For those who are joining us for the first time, this program is fully supported by Sabah Ministries of Science, Technology and Innovations. Furthermore, this STEM speaker series is a co-joint effort with the Faculty of Computing and Informatics, aimed to deliver unique and interesting STEM topic designed by subject matter experts to increase the interest of school students, teachers, and community alike to venture in the field of STEM. For any questions from our audience today, please feel free to drop your questions on the chat box at the right side of this YouTube Live session. Please be informed that today's session, e-certificate will be given to school students and UNS students, but must fill in the Google form to the link that will be shared at the end of this program. So please stay tuned with us. With us today is a distinguished academicians from Faculty of Computing and Informatics, University Malaysia Sabah. Associate Professor Dr. Azali bin Saudi. He is currently the Director of the UNS Campus Management Center. His research interests include the areas of computational mathematics, artificial intelligence, and robot vision. He had a PhD in mathematics from UNS, a master in artificial intelligence from the University of Edinburgh, and a bachelor degree in computer science from University Kebangsaan Malaysia. He has authored or co-authored more than 100 articles in journals, book chapters, and proceedings. He is currently a professor member of IEEE, SCN, and IEANG. He also leads research projects related to intelligent robotics, computer vision, deep learning, computing, and computational mathematics. So, without further ado, please welcome Dr. Azali with his topic, Robotic Kit for STEM Education. Dr. Azali, please be invited.
Okay, thank you, Ms. MC, Ms. Ipia. Okay, first let me share the slide first. Okay, my talk this morning, the topic is on robotics kit for STEM education. As you can see here, from Faculty of Computing and Informatics, currently leading the Intelligent Robotics Lab in the faculty. Okay, before we start with the robotics thing, let me talk about the trend from what we call Industry 1.0 to Industry 4.0. If you can see the timeline here, we start with the first industrial revolution in the 80s, and then followed by the second industrial revolution. So the first one involved first mechanical in the 1784. Then after that, we have second industrial revolution, where we start the mass production. And then in the early 2000, we have what we call a third industrial revolution based on the use of electronic and IT. This is to further automate the production. In the second industrial revolution, we have mass production. But in the third industrial revolution, we use electronic and IT to do the automation. Okay, now we are in the era of fourth industrial revolution. This is where we use what we call now cyber physical system. What do we mean by cyber physical system? Cyber represent in the layman terms wireless, something like wireless that you cannot touch. Whereas physical means something that you can see, you can touch, you can see it physically. So the combination of cyber physical represent what we call now fourth industrial revolution, or most commonly we call it IR 4.0. Now, this is something that I want to share, something that this is one of my hobbies, playing chess. One thing is this is something that very important, very interesting and very important in terms of achievement of machine. In the 1997, at that time, was beaten by a machine. So this is the first time machine defeated human in one of the tasks, which is playing chess. So this is because of the capability of the machine in doing analysis of up to 200 million positions per second, something that cannot be done by human. So this is one of the advantages by the machine, where the machine is capable of analyzing the position of the chessboard many times more compared to us a human. So this is in 1997. This is the first time machine defeated world champion, human world champion. So the machine is called Deep Blue, manufactured by IBM. Now, almost a decade after that, in 2016, this is another achievement where, again, machine. This one is Alphago. Alphago is a software. This time, the software beat the world champion at the time, Lee Sedol from Korea. So this time is a game called Go. Go is even now is considered beyond the reach of even the most advanced computer program. But it was proven in 2016. The software was capable of again defeated the world champion at the time. So this is another achievement in terms of software, in terms of program. Now, again, after 1 year after that, these two software, AlphaZero and Stockfish, these two software is very good in terms of how they attain the knowledge. So one of the idea is there is no more input from human. So the machine itself or the software itself do the training, what we call self-training. So over here, it takes only 4 hours for the software to train itself, to make it very good, to be software that capable of beating human in playing chess. So imagine here, human need years of training become a grandmaster or even expert, a good player in chess. But the software, it needs only around 4 hours to do the training. And the most interesting thing over here, the training is conducted by the software itself. This is what we call a self-training. Now, I want to share the relationship between, maybe you are quite familiar with the term AI, machine learning. Maybe some of you already familiar with it. Deep learning, this is another term. Now, AI terms come in the 1950s, and it is very, very popular for 3 decades until 1970s. And after that, new terms come out, and then we call it machine learning. This is until the 2030s, 2010s. After that, the new terms come with what we call deep learning. So deep learning is some new technology that not only in theoretical, now it is applied without you realizing it. So if you notice, for example, in Facebook, sometimes the Facebook will recommend you the face, recognize the face of the personality in your Facebook. That one is actually done by this new technology that we call deep learning. Now, this is what happened. In the beginning, robot operating by itself. But the trend now is to have the robot and the human working together. So as you can see here, this is in 23, KOKA robot. So this one is manufactured by in Germany. So what we have now is a collaborative robot where human and robot are working together in the workspace. So the focus here is how the human and robot working together so that they work in increase efficiency and making sure that the interaction is still safe. So this is an example of where the robot and the human working together to accomplish certain tasks. This is another example. Human and robot working together. So this is something that quite new actually, because yes, as I said before, in the past robot are working or operating by itself, but now the trend is to have the robot and human working together to perform certain tasks. So this is part of the industrial regulation 4.0, IR 4.0. And this is another robot. So as you can see here, the robot is looks very innocent. So the point here is to have the robot operating in to make it safe for the people to work around the robot. It is no longer a robot that looks very rugged, very not that safe. So the trend now is to have the appearance that of the robot looks more user friendly compared to the previous kind of robot. Now this is where robotics, where robots are applied. So as you can see here, robot is used in, of course, in the industry, in the healthcare, or even retail, tourism, agriculture, monitoring security, or in the education. So we cannot run away from robotics nowadays. Yes, robots now more frequently you can see robot walk around people. The robot is capable of obstacle avoiding obstacle. You can see the robot improve customer service. Yes, robot is everywhere. Now, industrial robotics. The current robotics is faster, more agile, but the most important thing is it becomes much cheaper compared to the previous generation of robot. It comes with integration of gripper, vision system, software, and various kind of control. Now, in terms of market demand of robotics, as you can see from the 1970s until today, the demand is keep increasing. So, okay, in terms of productivity, in the 70s, 80s, most tasks in the industry are carried out by human. And then in the 90s and 20s, early 20s, we have the robot operating by itself. This one contribute to the increase of productivity, but the robot is operating by itself. The robot are operating by itself. The current trend now is the robot and human are working together. And then as you can see here, the trend is still growing up. So this is the trend now. The human and robot are working together in the same workspace. Okay, this is the trend between the time and innovation. Okay. This is the interaction between a cyber physical system. As you can see the component over here, we have the robotics itself, we have the big data, and then we have the machine learning, we have the knowledge automation, and we have the hybrid manufacturing. And this is the component of cyber physical system. So as you can see here, robotics in the automotive industry. We use robotic for assembly, coating and bonding, to do the cutting, do the machine tending, and the welding, or even welding. We rely on robots to do precise welding, precise polishing, grinding. So all these tasks, of course, all these tasks can be carried out by human. But in the automotive industry, we want to have a uniform, and then uniform quality and fast production. Then it can only be done by automation in the manufacturing space. So this is the industry heavily relying on the use of robotics. So although most of the current robot is still operating by itself, but the trend is now to have the robots working together with human. Now, this is very interesting. in terms of market, the prediction by 2025. So you can see here the spending in terms of category of personnel, commercial, industrial, and military. As you can see here, the trending is upward for all category. So very close to exponential in terms of growing. How it grows from the 2000 and it only takes 25 years from 7.4 billion. Now it's multiplied by almost 10 times, 66.9, almost 67 billion. So that is how fast it grows in terms of market demand. Now in Malaysia, automation and robotics in Malaysia. So it is actually part of RMK11, where one of the key point over here is increase of industrial productivity through adoption of automation. So when we say adoption of automation here referring to one of it is, of course, robotics, automation. Yes, because in order to obtain fully automation, we have to rely on the use of robotics and similar technology. As you can see, this is one of our Proton Saga. And then this is 93. Of course, I think you all know Proton Saga is in the year of 1985. This is almost a decade after that. This is the second. This is the Pro2, Proton followed by Pro2. How are this car manufactured? This how the car are manufactured in the by the manufacturer. So as you can see here, it involves arm robotics to do some of the assembly of the car. Now this is what happened in Malaysia. In Malaysia, we have Malaysia Automotive Robotic and IoT Institute. So the campus is the headquarters is in Cyberjaya. So it is under the Ministry of International Trade and Industry, MITI. It is under MITI. And yes, we have the first outside building or outside branch of MARI, the institute. Is actually in Kota Kinabalu, and it is launched in 16 February 2019. So the headquarters in Selangor and the first branch outside Klang Valley is in Kota Kinabalu actually. So as you can see here, the aim is for technology adoption within the automotive, robotics, and IoT. So robotics is very close to automotive. And of course the IoT, very close, and these technology are very related to each other. Oh, this is also very interesting. Robot density in the G20 countries. So we have Korea, the first place. Density is 710 per 1,000 population. For 1,000 population, Korea have 710. Singapore not far enough from Korea. 658 of the 2,000 population employee. 10,000 employee. 658 are robots. Germany, half of it, 322, followed by Japan in the 4th place, 308. So this is the ratio between robot and the employee. So of the 10,000 employee, 308 are robots. And then we have Sweden, followed by Denmark, and USA is only 300. So Korea is almost 3 times. More than 3 times compared to USA. And China is only 79, 1% of the employee are robots. So this is the robot density in G20 countries. Now, this is the requirement by China. So it needs around 1.2 to 2 million robots if China want to have a high level of automation. And I believe China is going to try to achieve this. Malaysia is somewhere over there, slightly below China. Indonesia is better compared to China, compared to Malaysia. Indonesia, even Thailand. So this is the world robot population. World robot population. In 2006, the population is 4.5. 1 year after that, it increased to 6.5 million. In 2008, it is 8.6. This is the figure from 2006 and 2008. So you can imagine now the population is, of course, I think it will increase exponentially. But it is quite difficult to get the data because company tend to hide their profile. But this is the data that we get from 2006 and 2008. And then most of the population are more on service robotics. Service robotics. The blue one, the blue is service. The green one is industrial robot. So as you can see here, the trend is much faster. The growth is much faster in the service robotics. Service robotics. Now, the kit. So how do we play with robots in STEM? The one I've just shown to you is the real application of robotics. So to get familiarized with robotics technology, we have to play with what we call robotics kit. So one of the kits that you can play around is before that, when we talk about robotics, there are we want to have there are a few categories. What we call ground robotics. We have aerial robotics and underwater robotics. So this is part of aerial vehicle robots, UAV, unmanned aerial vehicle. So drone is one of the type of UAV drone kit. So this one you can program it yourself. You can program it using Scratch or very general programming language like Python or C# or even Java. You can write Java to program this drone. So this so you can use it to control how to take the picture of yourself, because this kind of robot comes with a camera and video. So it can be operated wirelessly, it can be controlled wirelessly. And it comes with 720p live view. So it also comes with a rangefinder sensor. So you can avoid obstacle. You can write the program so that the drone can avoid obstacle. Yeah. So this one is actually quite small, palm size drone. Another kit that you can use to play around with the robot things is what we call Aimbot. Aimbot. One of the advantages of this one, the chassis is compatible with Lego. So if you have Lego set, you can extend the robot, and then either to make it bigger, to make it looks better. Yeah, you can add additional Lego parts to the standard Aimbot chassis. This one can be programmed using Scratch and Aimbot. Either you can use Scratch or Aimbot to program this. And then it comes with Raspberry Pi, or you can use Arduino board to control this mobile kits. Okay, this one is I would say more advanced robot set. Lego Mindstorm Ev3. So this one is actually part of Lego product. You can use the provided programmer to write the program for this robot. And this robot is capable of producing sound, because it can do the walking, it can do the moving forward, turning left, turning right, moving backward, and so on. And it can also, you can write programs so that you can mimic the thinking. So you can write the program for this robot. So it comes with application so that you can write the program using GUI or using graphical user interface. This one is because this one is compatible with Lego part, so you can use any Lego part to make any kind of chassis. For example, here we have 3 type of design over here. So this Lego Mindstorm Ev3. So another Lego robotics kit. This is the latest one. Yeah, this is the latest one. This one, yes, very similar to the previous one, but this one is much smaller in terms of size. You can design various type of chassis design for this robot. Very similar to the previous one. You can have up to five different design, and then of course it comes with a controller that you can program. You can program so that the robot can walk and do the talking and much more. You can have it done, dancing and so on. Not forgetting underwater robot. So you can have this kit, underwater robotics kit. Of course, you can use this kit to do the how to construct a robot. How to construct a robot, and then learn the physics and the electronics of the robot. Maybe I can share the YouTube of this one. So I think I like to share this one. Let's share the okay, this is so you can see here students are competing each other in this one is underwater robot, ROV. Okay, a very short video. It demonstrates that anyone can play with the robot. Anyone can learn the robot. So that is one of the kits for underwater. If you prefer to play with underwater robot, that is one of the kits that you can use to construct the robot. ROV stands for remotely underwater operated vehicle. This is ROV kit underwater. Okay, this is another kit for robots. This one is what we call Turtlebot 2. This one is very good if you want to operate the robot for indoor application. And this is I think it's around 2 to 3 feet in height. So this one is very good. It comes with the camera, Kinect sensor. Kinect sensor is the one you use in Xbox, Microsoft Xbox. And it comes with power key base. The base is by default. The base itself comes with the obstacle avoidance capability. So the top one you can the tray. You can use the tray to carry light loading. So this one is quite stable for indoor office or any other indoor environment. Turtlebot 2. And the next version of Turtlebot is Turtlebot 3. This one is, in terms of size, is actually quite small. It is actually a palm-sized robot, very small. Over here, we have two versions of Turtlebot 3. The first one, the small one, we call it Turtlebot's Burger, and then we have the waffle pie robot. So this one comes with LiDAR. LiDAR is laser sensor that you can use to scan the surrounding. The robot comes with the LiDAR laser sensor. So the sensor is very good in scanning the environment so that the robot can sense the mapping of the environment. Again, this one is more suitable for indoor environment. This one is more suitable for indoor environment, office environment or house room environment. So we come to the conclusion slide. Okay, in robotics, there are two main components: the hardware and the software itself. Of course, the hardware, as you can see in the last few slides, you can obtain it from the market. Of course, there are many cheaper version, cheaper kit. You can buy now from Shopee platform, the cheap version of one. And then the controller, you can choose whether you use Arduino or Raspberry Pi. In terms of pricing, Arduino is much cheaper compared to Raspberry Pi. Arduino is around 25 ringgit or below. In terms of the software, the programming language, the simplest one is Scratch. Of course, there are Arduino IDE. If you want to have a more advanced control of the robot, you have to go for more general programming language like Python or Java or even C++. So again, depending on your this is where you learn STEM, where in robotics, because robot involve three type of domain, which is the mechanical, the electronic, and the mathematics. The electronics involve the programming, the physics, whereas the mechanical, the one is involved the chassis or the frame of the robot. The one involved mechanical. So three types of discipline are combined in order for you to design any or to construct any kind of robot. So basically, there are two components that very important here, which is the hardware and the software part. Okay, that's the end. Before I end up my talk over here, let me share this one more video. Warehouse robot. Okay. Share this one. This one. Okay, as you can see, the robot is no longer something that is a fantasy that you can only see in the movie. So it is now used widely in the industry. For example, here in the warehouse, the robot are fully utilized to increase the efficiency of the product delivery. I think that's the end of my talk today. So I pass the session to Miss MC kita. Yeah, thank you.
Thank you very much to Dr. Azali. It was a very interesting and wonderful topic and very well presented today as well as is relevant with the STEM educations. Now is the Q&A sessions. Please feel free to drop your question at the chat box and don't be shy. It is located at the right side of this YouTube live sessions. Hello, has sound or not? Okay. So the first question is, Doctor, just now you mentioned many benefits of robotics, but if use of robotics like smart pump factory at China are implemented at Malaysia too, do we have enough mature technology to support such technology?
Sorry, saya lupa ini ya. I forgot to unmute. Okay. Yes. In terms of physical material, for example, the microcontroller, the sensor, all this, we still relying heavily importing all the material from other country. This is the hardware part. But in terms of the software part, this one we can contribute. We can contribute heavily in this one. That's why in the first few slides just now, I focus more on the artificial intelligence, the machine learning. Those things are the software material. So software material can come from our own technology, because the only material you need is the software, the programming language that are mostly available as open source software. So you can write your own program. You can come up with your own AI algorithm. Then that one becomes your own our own technology. But the physical, currently we don't have the volume, the demand, big domestic volume. So economically, we still I think much better for us to get it from other country. So I hope this can answer the question. So the next question.
Okay, the next question, has sound or not? The next question is, what minimum age do you recommend kids to start learning about robots? And what is the best way to make them interested in robots?
Okay. Yeah. From our experience, school children. Okay. In the class environment, they learn, for example, they learn mathematics, they learn physics, they learn what else? Maybe some electronic or even some programming. Particularly the mathematics, the physics, mostly in theory. Now, when it comes to when they play with robotics kit, they apply the knowledge they have. To operate the robot, so they can see the what do you call, the product of their knowledge. When they apply the mathematics, the physics in their robotics or the programming language they learn, they can see the physical robot moving. They can see the result of whatever theory that they learn in the classroom. So from our experience, most of the participants, school children, they are very excited. They are more interested to learn, and then they even learn extra time. And then from our experience, they need very minimal coaching, minimal guidance. This is where you can see that they want to explore by themselves, and then they try to get the guides from the material from the internet on how to do the things. So at the same time, we encourage them to get the material, to get the reference material by themselves. Especially now, the reference material can be easily obtained from the internet, so they can learn by themselves actually, as long as we provide them with the kits. This is the what we can do to have the especially school children more interested in STEM discipline. Okay.
Okay.
Ada lagi?
For the last question, does this robot using programming logic law in artificial intelligence?
Yes. Okay. Depends. The simple kit, the one based on Arduino, it is quite challenging to embed with the AI. But robot that come with Raspberry Pi, that one is, because Raspberry Pi is more capable of processing higher logic or more advanced processing power. That one you can embed it with more advanced AI. For example, in the turtle board, that one is not only Raspberry Pi. It is actually, you can connect it to actual PC, so that the processing power come from the any fast computer that you have. Then the logic, any advanced logic from AI or machine learning or deep learning can be transferred wirelessly to the robot, so that the robot can operate based on the logic provided in the high-end computer. So again, depending on the robotics kit that you choose. The one that is very simple, it can only operate with very simple logic. Whereas the more advanced kit, you can have a more advanced AI logic. Yeah. Hopefully that answered the question.
Okay.
Okay.
That's all. We hope you all enjoyed this amazing and interesting presentation by our wonderful speaker today. The Google Form link is now being shared for school students and UAS students. Please fill in your details and answer the simple feedback questionnaire. All students will receive e-certificate, and for UAS students will receive SDP points. Thank you again, Doctor, for answering those questions and for the amazing presentations. Thank you also to all audience today for your participations. We look forward to see you in the next speaker series. It was a pleasure to have all of you with us. With this, we conclude this webinar. Thank you and see you again. Bye.
Oke, terima kasih semua. Oke, thank you Miss ya. Dan tim sana.